So I picked up my Scamp Lite. I actually went up to the factory in Minnesota, which was a great trip, and brought my Scamp back. I'm going to mainly use it for camping, but being this is more technical sort of channel, going to have a look at how I installed IoT into the Scamp. If you want more information about the Scamp Lite, which is a great little trailer, I'd recommend this Gearhead video. It does a good review of the Scamp. So just about the journey back, so I started from Scamp trailers up in Minnesota, stopped at a few spots on the way down, enjoyed the trip, and it really got me used to using the trailer, using some of the things like extending the mirrors on the RAV4, so I'm pretty comfortable with using it now. So most of this video is about adding the IoT board into the Scamp. So this is the IoT board I created in the last video, and I plan on putting it into the Scamp just here, close to the battery and the battery switch. So this is the circuit diagram that's included in the owner's manual for the Scamp. Wasn't totally accurate, it's sort of ballpark representation. So this is more what I found it to be like. So basically all the input power was coming in from the 7-way connector to the car, the solar controller, the battery, and the 12-volt converter all seem to combine at one point and are connected to one side of the disconnect switch, and then that switch then goes onto the fuse panel and distributed to all the 12-volt circuits, which was better for me because then I could just put a shunt in after the power connectors get combined and before the disconnect switch, and so I can measure current going into the Scamp when the disconnect switch is open. The other thing I did is I connected the actual IoT box of tricks after the shunt but before the disconnect switch, so it'll always be on, always drawing current, but also I can measure the current going into the IoT circuits as well, all the time, which was turned out to be handy. This shows the updated IoT board. I actually pulled out the UPS and just put in a 12-volt to 5-volt converter instead. Uses less power that way. I added a power switch just in case I needed to turn the whole thing off, and I did have some trouble with the INA 219 in the end. I think I must have blown it up. I had too much power through it, so I put a new one in. This is what it looks like in the front of the Scamp. So basically at the main switch I added an additional cable from the shunt, and then had all the 3 cables coming in from the battery, the 7-volt connector and the power converter all go to the top end of the shunt. One problem I had was there didn't seem to be a ground wire handy in that part of the Scamp, so I used one of the power outputs at the front of the Scamp, just under the sink, put a wire splitter in there and ran that out around to the IoT box to give me a ground. And finally I just added a trickle charger using solar in the front of the Scamp to keep the battery up. That's only a 20-watt charger, but it's good for just keeping the battery. So let's have a look at the results of this. So picking up things about the climate, the actual battery status, IoT information. So let's look at some of the results of that. So this is just looking over the last 3 days. Let's maybe just look at the last 2 days. So this is using my IOT system. I did another video on that, of putting that together, so if you're interested I'll put the link down in the description with a lot of the other links as well. But you can see here from the climate information for the RV, it's telling me what's the temperature like for the last couple of days. I also get things like the air pressure, the humidity, and this VOC, volatile organic compound. So it's kind of interesting to see how that varies. I'm probably going to have to look over a longer time, but basically the idea is the higher VOC number means the better the air quality. Lower means maybe some problems. I can kind of see it cycling during the day. I'm fairly close to a highway, so maybe it's when the turnpike starts up that there's more VOCs in the air, but I don't know if that's absolutely true. So I'll look at that over a few months and see if there's a pattern to VOCs, whether it's useful at all. Some of the other information, so under vehicle, again for the RV, I can have a look at what the house volts have been like for the last couple of days. Let's actually look at a week's worth of that. And I was away camping here, and here's where it's back in the backyard for me. And like I said, I've added a trickle charger, solar charger for keeping the battery refreshed up, and you can see that each day where it gets a bit of a spike in the voltage level as the battery gets recharged. But otherwise, end of the night, once the battery hasn't been charged by solar, you can see the voltage drop off, mainly probably due to the only thing that's running is the IoT system. If I'm interested in knowing how much power the IoT system's using, I can go to house amps. Again, I can see the amps when I was out camping, and here it dropped right away. So let's just look at the last couple of days. You can see it's pretty much in the 0.03 amp range. Works out at about 8-9 watts per day being used, so that should be more than enough for my trickle charge solar to keep up with. That's about the only drain on the battery if nothing else is running. And in theory, with the battery that I've got in there, 1000 watt lead acid, which I'd only want to use half of, so probably about 500 watts. It should be able to support the IoT system for about 50 days without trickle charging. So with the trickle charging, it's really not going to be a problem with keeping the battery up to 100% level. Some of the other things I can look at are things like IoT information, again for the RV. Picking up a lot of things, but one of the interesting things is this RSSI value, so that tells us how good the LTE connection is, and that's been fairly constant. LTE is working pretty well. The other things I'm picking up are things like how long it takes for the GPS to get a GPS location. That varies quite a bit, but that's probably just to do with where the satellites are in the sky when it tries to retrieve GPS information. What other things? Uptime seconds. You can just see how long this has been up, and number of files sent over the last couple of days. So typically it sends 4 IoT files per hour. A little bit of variance, maybe it's loses a connection over LTE sometimes, but you see when it doesn't get all the files transferred, it makes up for it on the next run, send those files that didn't make it on the first run. Some of the other useful things I'm getting from the RV, so if I just look at the status, I'm picking up the location for my RV, and this gives you a quick rundown of all the information that's available. This IoT system I'm using for a few things, so you see it also works for my boat there as well. I'm getting volt information, location information, climate information, and another thing I have on this IoT system is garden information. So again, just where the battery is as far as charge level and how long water's been run. So there's something useful I can do with the IoT data from the Scamp is I can see what my power usage is when I'm out camping. So like I said, I was out camping about a week ago, and what I did was I downloaded the amps used over one day when I was out camping. So this is the information here downloaded to an Excel spreadsheet. Again, that's something I can do in the IoT system, and that other video has more information on kind of capabilities there. But for each hour that I was there, it shows you how many amps I used. So kind of around dinner time, I used quite a few amps to cook some dinner just overnight, and other times I always had the refrigerator going, so that used some current to do that. Also had my laptop plugged in, and then various times I turned on lights inside the RV, so that used some of the amps as well. And in the morning I made some cups of coffee. I've got a little 12 volt kettle that I plug into the battery as well, so that's showing these spikes here is really in the morning getting some coffees, maybe 2 coffees, with the spikes there. So over the 24-hour period I can see how many amps I actually used from the battery. If I multiply that by 12, it tells me how many watts I used from the battery. I remember my battery's a 1000 watt hour battery, lead acid. They say you should only discharge it to 50% level, so that tells me I got about 500 watts I can use out of it. So in one day I used 315 watts. That's probably not typical if I was actually just doing 12 volt camping where I'm not plugged into power supply. In that case I'd probably run the refrigerator and the laptop off a Jackery rather than off the battery inside the RV. So it looks like I could probably get a couple of days fairly comfortably out of the battery that's built into the Scamp, and probably 3 if I really worked at it. But this gives me a way of at least monitoring that and keeps track of how much power I'm using. And then the voltage charts that we just looked at will tell me what's the status of the power and of the actual battery. So once we drop below about I think 12 or 11.8 volts, that's when you start getting worried about damaging the battery. So I can keep an eye on that as well to make sure I don't drop too low. So hopefully someone found that interesting. Again, I'm not going to do the typical camping in the Scamp type videos. Lots of other people do that and do it better than I could. So mine will be more about technology. So some of the other things I'm thinking of doing is adding some sort of cellular booster, maybe add a actual LCD panel to see this LCD IOT data inside the Scamp in real time. There's probably other things I can do there too that to do with technology, so that's probably where I'll be going with any Scamp videos in the future.